Section 4.2 is about exponential functions. So an exponential function is one in which the variable is in the exponent. Okay, so then you've got your base, which is going to be just some, it's going to be a positive number. The base is always going to be a positive number. All right, so let's see here. So the first thing it's showing us is just like a exponent rules here with the negative exponents. So if you have b raised to a negative exponent, that's the same thing as 1 over b raised to the positive exponent, or vice versa. Okay. Let's see. So number one, they're just asking us to like evaluate an exponential function with some given values. So if f of x is 2 to the power of x, then let's evaluate f of 3. So that would be 2 to the power of 3. So 2 times 2 times 2, which would be 8. All right, and then f of negative 4, so that would be 2 to the power of negative 4. So that's the same thing as 1 over 2 to the 4th power. And then 2 to the 4th power is going to be 16, so 1/16. And then part C, f of 5 over 2. So that would be 2 to the power of 5 over 2. Okay, so this is another important rule of exponents that we should already know, but maybe we don't. So the rule is, all right, let's see. Let's say we have x to the power of, let's say, p over n. That's equal to the nth root of x to the p. All right. So in this case, that would make that the square root of 2 to the 5th power. All right. And 2 to the 5th power is 32. All right, and then we could simplify that because we know that 32 is the same thing as 16 times 2, and we know that the square root of 16 is 4. So that would be simplified to 4 times the square root of 2. All right. All right, and then number 2, we have 3 to the power of negative x is the function. So let's evaluate f of 2. So that would be 3 to the power of negative 2. All right, so that would equal 1 over 3 squared, which would equal 1 over 9, 1/9. F of negative 4, so that would be 3 to the power of negative 4. So those two negatives would cancel each other out, and then that would just equal 3 to the power of 4. All right, and 3 to the power of 4 is equal to 81. All right, and then part C, f of 2/5. So that would be 3 to the power of negative 2/5. All right, so first of all, I would get rid of the negative, which would make that 1 over 3 to the power of 2/5. So then that would be 1 over the 5th root of 3 squared. So that would be 1 over the 5th root of 9. All right, and I'm just going to leave it at that. Okay. All right. Okay, so now let's talk about graphing exponential functions. All right, so f of x is equal to b to the power of x. Then here is a table, an xy table. So when x is 0, y is 1, because anything raised to the power of 0 is always equal to 1. That's one of the exponent rules. All right, now if you would like a review of exponent rules, you can always go to my my Math 0342 course and go to there's a video on exponents. It's 13.2 and 13.5, and it's all about exponents. All right. So, okay, anything to the power of 0 is 1, and then b to the power of 1 is b. So b can be any positive number here, okay? And then b to the power of negative 1 would equal 1 over b. And normally if I'm drawing a graph by hand, I don't bother with this one. This is more for like if your base is a fraction or something and you want to have negative 1 and then the reciprocal of the fraction. I've noticed on MyLabs Plus, they usually have you fill out a table, and they do usually include this in their table, this, you know, with fractions. So that is important to know. But like if I was just graphing it by hand, I would just skip that usually. Let's see. And then also I should have added onto my table the asymptote, because every exponential function always has a horizontal asymptote. And for the basic one, it's at 0. All right, so my 0 goes here, and that's undefined. So when I have undefined on my table, I know that's the asymptote, the horizontal asymptote. So the domain of an exponential function is all real numbers, and the range would be from 0 to infinity. All right, now, and that's assuming that you don't have a vertical shift. I don't think we have any. Actually, we don't do a whole lot of shifting with these for some reason, so you don't have to worry about that. But I mean, it could be shifted up and down. So that's the shape of an exponential function whenever b is greater than 1. If b is less than 1, then it's flipped this way. All right. Okay, so let's start doing some examples. So 5 to the power of x. So your table so it'd just be 0, 1, 1, 5. I mean, you could have negative 1 and then 1/5. And then undefined at 0, that's your horizontal asymptote. So you've got your horizontal asymptote is at 0. And then 0, 1, 1, 5. and -1 1/5 would be like down here. All right. So again, like I always say with graphing, I always recommend that you get some graph paper somehow. You can print it out for free online, and do these graphs by hand on paper. And then when you're doing your homework and stuff on MyLabs Plus, go in and try to make your graph on the computer look sort of like the graph that you drew by hand. So that's my recommendation. Okay, and let's see. So number 4, 3 to the power of -x. So that is also the same thing as 1/3 raised to the power of x. Okay, so whichever one of those appeals to you, it doesn't matter. They're both the same. All right. So the table for this, so we still have 0, 1. You would have 1, and then your base is 1/3. Okay, going off of this, and you'd have -1, and then the reciprocal of your base, which is 3. And then you've got your asymptote at 0 still. Okay. Okay. So here's the asymptote. And you have a point 0, 1 as always. And then -1 and 3. So there we go. There's our graph. Okay, number 5, 1/2 to the power of x. Okay, so that is the same thing as 2 to the power of -x, if you prefer to look at it that way, whichever. So you're going to have 0, 1, 1, 1/2, -1, 2, undefined, 0. That's your asymptote. There's your graph. Number 6, 1/4 to the power of -x. So that is the same thing as just 4 to the x. So that's definitely easier to work with. Okay. There's the asymptote. And there's the graph. All right. Okay. All right. And next we have solving exponential equations. All right. So number 7, it says 2 to the power of x is equal to 32. So I'm just going to ask myself, 2 to what power is equal to 32? Okay, well, I know that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 2 to the 5th power is the same thing as 32. Okay, so that's a pretty easy one. So just rewrite, instead of 32, that's the same thing as 2 to the 5th power. And then we can see that we could cancel out these 2's, and that would just leave us with x is equal to 5. Okay. Number 8 says 4 to the power of 3x minus 5 equals 16. So what I'm going to do is try to, so I want to rewrite, instead of 16, write that as 4 to a power. And I'll just bring this side down for right now. Okay, so 16 would be the same as 4 squared. So now what I've done is I've written both sides using the same base, and then I can cancel out those 4's. So then that would just leave me with 3x minus 5 equals 2. Okay. And then I can just add 5 to both sides, which would give me 3x equals 7, and then divide both sides by 3, so x is equal to 7/3. Okay. All right. Number 9, 3 to the power of 7x equals 27. So I want to rewrite and replace 27 with 3 to a power. Okay, and I'm going to bring down the left side, 3 to the power of 7x. So 27 is the same thing as 3 to the power of 3. So then I'm able to just cancel out the big 3 bases. All right, and then I can see that 7x is equal to 3. 7x is equal to 3. And then in order to solve for x, just divide both sides by 7. And that gives me x is equal to 3/7. All right. Number 10, 2/3 to the power of x equals 9/4. So we're going to try to replace 9/4 with 2/3 raised to a power. Okay. And I'll bring down this 2/3 to the x. Okay. So, let's see. Well, if, I know that, 3 squared is 9 and 2 squared is 4. So I could say that this is the same thing as 3/2 squared, right? And then I just need to flip that. So to flip it, you make the exponent negative. So it's an exponent of -2. So 9/4 is the same thing as 2/3 raised to the power of -2. So then you would just cancel out the 2/3, and then you would have x is equal to -2. Okay. All right. Number 11, e to the power of 3 minus x equals e to the power of 3 to the power of -x. Okay, so we haven't really talked about e yet, but e is a constant, kind of like pi, and it doesn't really matter anyway in this case because we're going to end up canceling it out anyway. We do need to use another one of our exponent rules because e to the power of 3 and then raised to the power of negative x. So if you have something that's raised to an exponent and then all that is raised to another exponent, to simplify that, you would multiply those exponents. Okay, so this turns into e to the power of negative 3x because I multiplied the exponents. So e to the power of 3 minus x equals e to the power of negative 3x. So then we can just cancel out the e, and then we just have 3 minus x equals negative 3x. Okay, all right, so now we're going to try to solve for x. So we would need to have all of the x's onto one side. So you can go either way. Let's just make it easy and add x to both sides. So that would be 3 equals, so that's like a 1x, that'd be negative 2x. And then just divide both sides by negative 2. So that gives me x equals negative 3/2. Okay. All right, so number 12, we want to try to write both sides using the same base. However, 16 squared is a lot bigger than 32, so it's 16 and 32. It's going to be a smaller number. All right, so try to think of what would be a smaller number that could be used as a base for both the 32 and the 16. Okay, so usually it's going to be a prime number. The prime numbers would be like 2, 3, 5, 7, 11, okay, etc. All right, so in this case, the base that we're going to need to use is 2. Okay, because we know that 2 to the 5th power is 32 and 2 to the 4th power is 16. All right, so 32 is the same thing as 2 to the 5th power. And 16 is the same thing as 2 to the 4th power. All right, so this one is still raised to the power of t plus 1. This one is still raised to the power of 1 minus t. Okay, so when you have something with an exponent and then it's raised to another exponent, you're going to multiply the exponents. And we could go ahead and cancel out the 2's, basically. So the 5 is going to be multiplied by the t plus 1. So it's going to be multiplied by the whole thing. So I'm going to keep it in parentheses. And then the 4 is going to be multiplied by the 1 minus t. Okay. So distribute the 5. So that's 5t plus 5 equals, and then distribute the 4. So that's 4 minus 4t. Okay, so we have to get all the t's over to one side. So let's add 4t to both sides. And while I'm at it, let's just go ahead and subtract the 5 from both sides. So 5t plus 4t equals 9t. And then 5's cancel out there. 4 minus 5 will be negative 1. 4t cancels out, so we just have 9t equals negative 1. All right, so then let's do divide both sides by 9. So that gives me t equals -1/9. All right, number 13, we have the cubed root of 5 raised to the power of x, and then we have 1/5 raised to the power of x plus 2. So again, we're trying to use this, get the same, both sides written in terms of the same base. So, and like I said, it's usually a prime number, and in this case, that number is going to be, all right, so we have to write this and this using the same base number. So that base number is going to be 5. So the cubed root of 5 is the same, we're trying to write that as 5 raised to a power. Okay, so the cubed root of 5 is the same thing as 5 raised to the power of 1/3. And then 1/5 would be the same thing as 5 raised to the power of -1. Okay. And then on the left side, that's still raised to the power of -x, and on the right side, it's still raised to the power of x plus 2. All right, and we're going to multiply the exponents, and we're going to cancel out the 5s. Okay, so 1/3 times -x, so it would be -1/3 x equals, and then we've got to multiply -1 times x plus 2, so that's going to make that -x minus 2. Okay, because you're basically just, I'm just distributing that -1 multiplied by x plus 2. Okay, so -1/3 x equals -x minus 2. So I have to get, let's see, I have to get the x's to one side, and if you want, we could probably make this a little bit easier by multiplying everything times like 3 or even -3, you know, whatever you want to do. As long as you do everything, you know, all the way across the equation, you can do it however you want. Let's multiply everything by -3. That way we'll get rid of that fraction, and we'll get rid of all those negatives at the same time. So -3 multiplied by -1/3 would just be +1. So that would just be x equals. All right, and then -x times -3 would be 3x, and -2 times -3 would be +6. Okay, so that looks a little bit prettier. Okay, and then let's get the x's to one side. So let's subtract 3x from both sides. And that gives us, so that's like a 1. 1 minus 3 is -2. So -2x equals 6. And then go ahead and divide both sides by -2. And that would give me x equals -3. All right. Okay, and number 14, we have r to the power of 4/7 is equal to 16. So in order to get r by itself, what we want to do is raise both sides to the reciprocal of that fraction exponent. Okay, so raise both sides to the power of 7/4. Okay, so that'll cancel out. So that will cancel out with that, and that'll just be r equals. And this is going to be, okay, so 16 raised to the power of 7/4. So that equals the 4th root of 16 to the power of 7. So it doesn't really matter if you put the power of 7 in here or out here. I'm going to put it out here this time because I can simplify that 4th root of 16. So if I want to evaluate the 4th root of 16, I just need to know what number raised to the power of 4 equals 16. Okay, so that would be 2. 2 raised to the power of 4 is equal to 16. So that would be then 2 raised to the power of 7. Okay, so I already know 2 to the 5th is 32. So I just need to multiply that by 2 more 2's. So 32, okay, and so that would mean multiply that by 2, that gives you 64. Multiply that by 2, that gives you 128. Okay, so that's equal to 128. All right, and that's the end of section 4.